Hello there guys, welcome back to another epic inexorable maths video. In this video we're going to find the Laplace transform of e to the at. So this one shouldn't be too bad because we know what the Laplace transform is. It's defined as f of s, capital F of s, where that's equal to the integral from 0 to infinity of the original function f of t multiplied by e to the minus st dt. So our f of t is e to the at. Let's go straight ahead, dive straight in and get a value for the Laplace transform of e to the at, where a is a constant. So let's go for it. We just plug this into our integral. So this is going to be an integral from 0 up to infinity of f of t, which is e to the at. So e to the at times e to the minus st dt. Okay, we can then use index laws to write this as e to the a minus s t dt, like that. So we're just multiplying them out, adding the at and the minus st, and then factorising that, and you get e to the a minus s multiplied by t. Okay, so at this point, why don't we start putting in a variable that can then go to infinity, because clearly this is an indefinite integral. So let's say this is equal to the limit, and I'm just going to make up a letter. Why don't we say y, as y goes to infinity, of the integral from 0 to y of e to the a minus s brackets t dt. Like that. So I'm just adding in our, just so we can do it formally, adding that in. Lovely. Okay. Now, how are we going to compute this? Well, this is an integral that we can actually do quite nicely. So this is the limit as y goes to infinity, and now we're actually going to do the integration. So remember, when you have e to the power of a constant times some variable, when you integrate this, it just becomes 1 over, in this case, it will be a minus s, and then multiplied by the same e to the a minus s t. That never changes. It's in brackets, and we're evaluating from 0 up to y, as y goes to infinity. Okay, now let's plug some values in. So we've got limit y goes to infinity. Okay, so now we've got 1 over a minus s e to the brackets a minus s close brackets y minus, and then let's see what happens when we get our minus involved here and our 0. So let's go 1 over a minus s e to the power of a minus s times t, but t is 0, so it's e to the 0, which is obviously 1. Okay, right, I'm going to come up here now. So this is equal to the limit as y goes to infinity we've got 1 over a minus s e to the a minus s y, so 1 over a minus s e to the a minus s y, and then let's just do this here. So e to the 0 is 1, so this becomes just minus 1 over a minus s. Okay, now here's the thing. We need this to converge. Now, if you plug in as y goes to infinity here, this will converge or not converge based on what the value of a is, because we want the number in front of y to be negative. So what we need is either a or s to be values such that this thing converges and it gives you a negative number here. And because, I mean, preferably you just say, well, okay, that's fine. A just needs to be less than s, because if this is the case, then this is a negative number. However, we don't really want to do that because I want to be able to choose any value for a that I want. I want the Laplace transform of e to the 5t, e to the minus 10t, e to the minus a million t, e to the half t. I want to choose any value. So I need to put a restriction not on a actually, but on s. And so I'm going to say, as long as s is greater than a, then this will converge, because we're doing a number, take away a number that is larger, because s is greater than a. If this is the case, then we've now got the limit, or we don't even need to do this. As long as s is greater than a, it's a negative number here. And as we take the limit of e to the negative infinity, that's going to go to 0. And so our Laplace transform of e to the at is just 0 minus 1 over a minus s. This term here is 0. Now minus 1 over a minus s is just 1 over s minus a. Okay, and again, we're saying that s is greater than a, just like that. Okay, this is the Laplace transform of e to the at. So for example, the Laplace transform of, let's say, e to the 5t would be 1 over s minus 5. Lovely, and that's it. Thank you guys so much for watching. Highly appreciate it. I'll see you in the next video.